Hello everyone and welcome to Van Tech Corner. In the previous video, we have an overview of the NanoPi R5S. In this video, let's have further testings of the NanoPi's performance in OpenVPN, Wireguard VPN and NAT. And before we proceed with the test, I will update the NanoPi R5S to the latest release. So if you go over to the wiki page right here, you will have the install OS selection, okay? And actually there are several ways to install the update of the OS. You can do it via the web page, or you can do it via a micro SD card, or you can do it with the USB cable. And to make it easy, I'm going to install the update with Lucy, okay? So you will need to get the file name starting with SD, okay? So just on the install OS section, you will have a download link right here. If you click on that, it will open two links. One is a Baidu and another one is Google Drive. Let's click on this one and you will have something like this, okay? So let's go to the official image. And then let's go to the SD card image, okay? So right here you can see that we have the RK356A-SD. So this is the image that we're looking for. And we have two options. This is the FriendlyWRT with no Docker, and this is the option with Docker. So let's just give it a try with the Docker version. Let's download it. Alright, so we can see that the file had been successfully downloaded, and let's go to the Lucy page to proceed with the update. So let's go to System and then Backup and Flash Firmware. Click Flash Image. Browse and select the image that we have just downloaded. Okay, let's click Upload and just leave it for Lucy to handle the upgrade. I don't think we need to keep the setting, so just deselect this one and hit Continue. Meanwhile, we can just open CMD and ping the router. We can see that the router had just come back online. Let's manually refresh the page and log in. The default password is root and then passwords if you don't know. So let's go to System Administration to update the password. Very good. We are now in the latest release and we can see that it's OpenWRT 21.02.3 and the kernel version is 5.1.110. So now we can see that the one port is Ethernet 0 and this port is just 1 gigabit per second. So in order to fully utilize the 2.5 routing, I'm going to convert one of the LAN port to the WAN port. Okay, so let's give it a try. Let's go to the device tab and then right here we have Ethernet 1 and Ethernet 2. I don't know which port is up and running, so let's just connect to the router V888H. Okay, so if with an IP link, let's see what do we have. Ethernet 0, this is our one port and we can see that it is 1000. Okay, Ethernet 1 and Ethernet 2, it is up and the Ethernet 1 is down. Okay, so this Ethernet 1 is the LAN port with the label LAN 1. Alright, so I'm going to convert this Ethernet 1 to the WAN port. So let's do that. So let's go to the bridge LAN configure and I'm going to remove Ethernet 1, hit save. Alright, and then save and apply first. And actually right now we don't need the Ethernet 2 in the LAN bridge anymore, because we can just directly create this interface from the physical interface instead of the bridge. So I'm going to change the device of the BR-LAN to Ethernet 2 and hit save and apply. Alright, so I'm just remove the LAN bridge from the router. Very good, we can see that. And somehow it is still BR-LAN. Let's refresh the page. Alright, we can see that it is now Ethernet 2. Okay, very good. And now I'm going to change the one port right here to the Ethernet 1. Hit save and modify the 1.6 also to the Ethernet 1. Save and then save and apply. Alright, so right now I'm not sure. I think there's something wrong. Okay, yes, we need to manually refresh the page anyway, and we need to restart the section root and log in. So we have Ethernet 1 and Ethernet 2. The Ethernet 1 is the one port right now and it is down, and the Ethernet 2 is the LAN port. Okay. Now I'm going to remove the Ethernet cable from the one port, which is 1 gigabit, and connect to the new LAN 1 port, which is right now in the one port with 2.5 gig. Let's connect that. And after refresh the page, we should see it up and running. Let's check it out. Alright, we got the IPv4 address already. So 192.168.100.103. Alright, so after we have successfully configured this, we have this network diagram. So this is our internet provider. Go to the FastReno R68S, and this port have two 2.5 gigabit Ethernet ports. So I'm going to connect my R5S and my test server to the LAN port. Okay, so this connection is 2.5 gigabit per second, and this connection is also 2.5 gigabit per second. Alright. So this one is the one IP address 192.168.100.103. On this side 102. And after it go to the NanoPi have the LAN IP of 192.168.2.0. So this link is also 2.5 gigabit. Alright, so we have a fully 2.5 gig connection from my PC to the NanoPi R5S, and also to the FastReno, also to the test server. So right now, if you look at this setup, this test server is on the one side. So we can run the OpenSpeedTest or iPub3 test and OpenVPN and Wireguard VPN test from my PC through the NanoPi R5S and to this server. Okay, so let's do that. Alright, so now let me run htop. Okay, so htop is not found. So let's run opkg update first, and then opkg install htop. Let's just minimize this one. And before we proceed with the test, let's go and confirm if the SQMQS is disabled. Yes, everything is disabled, and let's see the firewall. We have the shortwave offloading. Let's just disable it as well, and let's do that. Alright, so let me open another tab so that we can see the CPU utilization. Alright, let's go. That is good. Let's run it for another time. And for the second test, we can see that the speed is only 650 Mbps. and the CPU is 60% idle. So now with the upload, we can see that it's already go to 1450 and the CPU is at 53% idle. Let's refresh the page and run the tests for the lag time. Very good, we are now reaching 1165 with the CPU at 41% idle. And here we can see on the H-top interface, the load is shared across all the CPU of the NanoPi R5S. But we can see that the download and the upload speed is not stable and not the same across all the tests. So sometimes the download speed is fast and sometimes the upload speed is fast. So let's check it with the iPerf3 test because I believe it should be better. Alright, so let me open the terminal to 192.168.100. Oh, I'm sorry. Let me open the SSH connection to 192.168.100.102 and log in. iPerf3-S-D. Alright, that is good. Now on my local PC, let's go to the iPerf3 directories and iPerf3 c192.168.100.102.t, maybe 40. Let's see. So we can see that for iPerf3, the throughput and the speed is not really good. It's only 607 megabits per second. Let's run the test for another time, but this one just go with the default. So unfortunately, the speed is slower compared to the previous test. Let's go to the configuration files and turn on the shortwave offloading. Shortwave offloading enable, save and apply. And let's see if we have any changes. So now let's give another try with the OpenSpeedTest and shortwave offloading. So with the shortwave offloading enabled, I'm able to get 1241 Mbps for download and 1106 Mbps for the upload. Let's run the test for the second time. We are reaching 1800 Mbps and the CPU is at 46.5 idle. This is a really good result to see, but let's check out the upload speed. So download 1800 and upload only 1300. Let's give it another try and let's see. Alright, so we can see that the result is not really stable. So right now we can see that the download is 793 Mbps and the upload speed is 1338 Mbps. This is not really a stable result, so let's check it out with iPub3. So no matter what you do, the speed is still 600 Mbps, around that for iPub3 test. So it is 641 Mbps for iPub3 test with the CPU offload enabled. So far we have just done the 1-2 LAN throughput test, and we are running the test from my PC right here to the test server right here. And we can see that the speed is not really stable when we are running different tests on OpenSpeedTest as well as the iPub3 test. So I'm just leave it for now because we need to move on for sure. So let me set up OpenVPN and Wireguard VPN, and let's see what can this router do. Okay, let's do that. Let's go to the software and search for OpenVPN. Alright, so OpenVPN SSO. And then loosely up OpenVPN. We can see that the OpenVPN terminal is up and running, and let's check the IPv4 of OpenVPN. So 10.8.0.1, let's try to ping that. Ping. And we have no response. Did I mess up something? OpenVPN, Wireguard VPN. Okay, let's see. OpenWRT. Let's go to the VPN, OpenVPN. Let's go to the edit buttons, and alright, everything is good so far. We can see that it is running, but what is wrong? Alright, it looks like we need to restart the router before OpenVPN start to work. So let's do that. Let's go to System, Reboot, and perform a reboot. So let's see if the router is up. Let's restart section root. Very good. Next top again. Restart. Root and the passwords and top. And let's see if we can reach the OpenVPN virtual IPv4. Very good, we have the response. So let's check it out. Let's log in, and we can see that everything is ready. We have the terminals up and running right here. So now I'm going to change this IPv4 to 10.8.0.1. 8.0.1/3000. Let's start the test. We are running at 160 Mbps, and we can see that one of the core is 100% loaded. Alright, so as I have mentioned so many times, OpenVPNs only utilize a single core, and for this SoC we reach the maximum download and upload at 162 Mbps. Let's run the test for the second time. We can see that the result is very close to the first one, 155 Mbps for download and 145 Mbps for upload. Alright, so let's run the test with iPub3. So as usual, iPub3-C, and then it will be 10.8.0.1T, maybe 40. Let's see. So one of the cores is 100% loaded, and we have 150 megabits per second. Alright, so I think this is true. The maximum OpenVPN throughput for this Rockchip RK356K SoCs is 150 megabits per second. Let's do another test for the Wireguard VPN. And right now I will need to stop the OpenVPN, just stop the one, and then let's go to this OpenVPN and untick this one and hit stop and hit save and offline. And to be sure, I'm going to click on the edit button and untick the bring up on boot. Alright, so let's go to the system software update list, and we are going to install Wireguard VPN. Right now, the R5S is very hot, and I can feel the hot when I put my hand on the case. I'm not sure if we can see the temperature right here. Unfortunately, no. Let's run Wireguard. Let's run Lucy up for Wireguard, and I believe it should help us to install the rest of the package. Very good. So let's go to Network Interfaces and add a new interface, and let's see if we have Wireguard VPN. Alright, no. So let's go to System Startup, and let's see if we can restart. So it should be HTTPD restart, and then alright, network restart. The connection is down and it will be up shortly. Let's go to Network and Interfaces, add a new interface, and we already have the Wireguard VPN. That's good. WGs and the protocol is Wireguard VPN create interface. So right here I already have the configuration files. So let's just open it with Notepad and let's copy one by one. Alright, so this is the private keys of the interface. The listen ports, let's put it randoms and IPv4, it should be this one. Okay, that's good. Let's go to the firewall and put it to the one, and go to the peer and add a new peer. Don't update the public key, pre-share key, the allows IP address, it should be 000.0/0, which is all of the IP address will be routed through this interface. Select route allow IPs, endpoint, and the port. Alright, that is good. So right now we are not behind NAT and we're directly connected. So I just leave it for 0, save, and then save and apply. Let's refresh the page. And we already have some TX, but there is no RX. Let's refresh another time. Status. Let's just log out and log back in. Status. Wireguard. Last handshake, never. Something is wrong. We got no RX, and I believe we need to reboot the whole system. Let's give it another try. So right now the Wireguard interface is up and running, and for now I only input the endpoint hosts. That's why the connection is not up and running, but I have corrected and updated to 192.168.100.102, and it's up for now. Optional, the second between keep alive message. I think we can just put it 25. It doesn't matter. And according to our network diagram right here, the IPv4 address of Wireguard is 10.7.0.1. So here it is. Let's go. Alright, so we are running at 637 Mbps with 30% CPU idle. This is a very good performance of Wireguard on the R5S. And we receive the same speed, the same upload speed, and it is around 610 Mbps. We can see that the load is on all cores. Very good. Let's run the test for another time. Connecting to Google Analytics. Alright, so let's start. So this time the download speed is only 290 Mbps. And the upload speed is 560 Mbps. Maybe something is wrong. I need to run another test to confirm this. Let's go. Running the test for the second time, I got 610 Mbps download with the CPU at 27% idle. And for upload, we are reaching the same speed with the CPU at 38% idle. Alright, that is a very good and stable result. Let's give a try with iPub3. So it will be iPub3.c and 10.7.0.1-T40. We have a very stable throughput at 482 megabits per second. Let's run the test with the default argument and let's see. Alright, so with iPub3 result for the Wireguard VPN client, we have 480 megabits per second. And with OpenSpeedTest, we can see the speed is up to 600 Mbps. Okay, so I think this will be too long for the test. And maybe in the next videos, I will check out the SQMQS performance as well as the M.2 speed with SMP, and let's see how it's going to do in file sharing. So that's all. Thanks for watching and see ya.